In this video, we are going to focus on solving rational equations. There are several different methods of solving rational equations. I'm going to be focused on one method where my first goal will be to clear out the fractions. So here are the steps. Step number one is determine the domain of rational equations. That means all the numbers that do make the denominator 0 are not a part of the domain, excluding those numbers. So you don't have to use them right now, but just keep them in the back of your head, or it's okay to write them on a side somewhere that these are unallowed numbers, these are restricted numbers, these are the numbers that's not okay, that's not a part of my domain. Okay, so determine what is in the domain and what's not in the domain. Second step, determine the LCD of all the denominators, both sides of the equal sign. Determine the LCD of all the denominators. The next step is multiply both sides by the equation, multiply both sides of the equation by the LCD and simplify each side of equation into polynomials. So in step number 3, when we multiply both sides with the LCD, we will clear out the fractions. No more fractions will be left. Next step, solve the resulting polynomial equations using factoring and the zero product property if needed. Last step, verify your solutions using the original equation. That means you plug your solutions back into the original equation. They should make the left side equal to the right side. Make sure they are in the domain of the equation, that they're not extraneous solutions. So they're not the solutions that would make your denominator 0, that would make the function undefined, or that would make your expression undefined. So they are not going to be a part of our solution if you have any such numbers. Let's look at some examples. Example number 1, solve 2 over 2x minus 5 equal to 6 over 2x minus 3. So my first goal is to determine the LCD and then multiply both sides with that LCD. LCD in this case will be 2x minus 5 times 2x minus 3. We did a lot of examples of LCD when we were adding or subtracting rational expressions. So I'm gonna, after we find the LCD, multiply both sides with the LCD, which is 2x minus 5 times 2x minus 3. Now we're going to be distributing this into both sides of the equation. So 2 over 2x minus 5 times 2x minus 5 times 2x minus 3 equals 6 over 2x minus 3 times 2x minus 3 times 2x minus 5. Let's get rid of the common factors. So 2 times 2x minus 3 equals 6 times 2x minus 5. And now I'm going to be distributing and combining the like terms and solving for the variable here. So 2 times 2x is 4x minus 2 times 3 is 6. 6 times 2x is 12x minus 6 times 5 is 30. Let's go ahead and bring all the variables to one side. I'm going to be subtracting 4x from both sides. So subtracting 4x and 4x, negative 6 equals 8x minus 30. Let's go ahead and add 30 to both sides because we are trying to isolate the variable. Divide both sides with 8. X turns out to be 3. Now, before I box this answer, before I say this is my final answer, I need to find the restricted values and make sure that 3 is not one of the restricted values. How do we find the restricted values? Restricted values are the ones that will make my denominator 0. So what value of x will make this denominator 0? That would be 5 over 2. How do you find that out? You can set that denominator equal to 0 and solve for x. And same way, we can look at the next denominator, 2x minus 3. That would be 3 halves. That will make my denominator 0. These are the restricted values. And the solution I got is not one of those. So that means we do have, this is our solution. Okay. If it turns out that the solution to the equation is one of the restricted values, then that is a extraneous solution. We cannot include in the solution set for our rational equation. Let's look at example number 2. 4 over 3b plus 1 over 6b equal to 7 over 2b plus 1 over 3. Let's think about what is LCD in this case. LCD, remember, LCD is going to be do the prime factorization of each denominator and then bring out each unique factor to the highest exponent. So in this case, LCD is going to be 6b. So I'm going to go ahead and multiply both sides of the equation with 6b. Go ahead and distribute, 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 distribute. So 4 over 3b times 6b plus 1 over 6b times 6b equals 7 over 2b times 6b plus 1 over 3 times 6b. Let's go ahead and simplify between the fractions. So that's going to leave me with a 2. That was a 6b and they cancel. Plus 1, 8 plus 1 equal to b and b is gone, and there's going to be 3. 7 times 3 is 21 plus a 2b. So 9 equals 21 plus 2b. Let's go ahead and subtract 21 from both sides. So subtract 21. 9 minus 21 is negative 12 equals 2b. And negative 12 divided by 2 is b. Turns out to be b is negative 6. Before I box this answer, before I say this is my solution, I must check and make sure that this is not extraneous solution. This is not a restricted value. What is restricted value in this case? Restricted value in this case is the value of the variable that will make my denominator 0. So what's the value of the variable that would make these denominators 0? Well, only b equals 0. That's the restricted value. And that's not what I got as my solution. So it's okay to go ahead and circle, box, highlight this solution and say this is the solution to this rational equation, b equal to negative 6. b equal to negative 6. Okay. Next example, we have number 3 here. Looks a bit more complicated, bit more work, but I think let's go ahead and start by figuring out the LCD here. So we want to figure out the LCD. We wouldn't know what LCD is until we have factored all the denominators. So let's go ahead and factor the first denominator, which is x squared plus 3x minus 4. Two numbers multiply to give you negative 4, add up to give you positive 3 are x plus 4, x minus 1, and 3 over x minus 1, and then we have minus 2 over x plus 4. So it looks like LCD in this case would be x plus 4 times x minus 1. Once we found the LCD, we're going to multiply both sides of the equation with that LCD. X minus 1, x plus 4. It is time to distribute the LCD into the entire equation, both on left and right hand side, and cancel the common factors between numerator and denominator. On the left side of the equation, we'll be just left with x squared plus 8x plus 6. On the right side of the equation, we would be left with 3 times x plus 4 minus 2 times x minus 1. So there needs to be some work done here. Combine some like terms. So leaves me with 3x plus 12 minus 2x plus 2, which is x squared plus 8x plus 6 equals 3x minus 2x is x. 12 plus 2 is 14. X squared. We will subtract the x from both sides plus 7x, and we'll subtract the 14 from both sides as well. 6 minus 14 is negative 8. Now this is a factorable equation, so we can go ahead and factor x plus 8, x minus 1 equal to 0. So my two solution turns out to be x equals 1, and x equals negative 8. X equals 1 and x equals negative 8. Now, before we box circle these answers, we want to make sure that they are correct answers. They are not extraneous solutions. They do not make your equation undefined. They don't leave you with the 0 in the denominator. So let's go ahead and plug, see if x turns out to be 1, what are the extraneous solutions? Let's think about extraneous solutions. They're also called restricted solutions, not allowed solutions, all kinds of names for them. Extraneous solutions in this case are x equal to 1 and x equals -4. These are the two numbers that will be not allowed to be the solutions. Why? Because they make your denominator 0. So x equals 1 is not allowed, x equals -4 is not allowed. So here's my troublemaker, x equals 1. That's not going to be a part of my solution. The only one we're going to include is x equals -8. That is my only solution, because x equals +1 is not an allowed solution. Okay, next example, 15 over x squared plus x minus 6. Let's go ahead and factor the denominator so that we can easily find out the LCD. Plus 3 over x minus 2 equals 2 over x plus 3. All right, now we're going to multiply both sides, x plus 3, x minus 2. That's my LCD here in this case. So I'm multiplying both sides of the equation with the LCD. And now I'm going to distribute the entire LCD into both sides. Multiply the LCD into with each fraction. So that's just using the distributive property. X plus 3, x minus 2, plus 3 over x minus 2, x plus 3, x minus 2, and the other side I have 2 over x plus 3, x plus 3, x minus 2. All right, let's cancel out the common factors between numerator and denominators, and looks like we are left with 15 plus 3 times x plus 3 equals 2 times x minus 2. All right, 15 plus 3x plus 9 when we distribute equals 2x minus 4. 15 plus 9 is going to be 24 plus 3x equals 2x minus 4. So go ahead and subtract 2x from both sides. I'm trying to bring the variables to one side. 24 plus x equals -4, and then subtract 24 from both sides. That leaves me with x equals -28. Now, before we box, circle, highlight this answer, we must check if that 28 is one of the extraneous solutions. Extraneous solutions are the ones that make your denominator equal to 0 for the equation. So what would be extraneous solutions in this case? Well, think about the numbers that would make these denominators 0. What values of x will make the denominator 0? Well, that looks like it would be x equals 2 and x equals -3 are not allowed numbers, but this is not one of them. So it's okay to go ahead and box, circle, and say, okay, this is our correct answer. Right, next we have number 5, 3x over x plus 7 minus 3 over x minus 2 equal to, remember this negative sign is actually with entire numerator, so keep in mind. Now my first goal is to find LCD. We cannot find LCD until my denominators are in the factored form. 3x over x plus 7 minus 3 over x minus 2 equals -5x plus 17 over x plus 7 x minus 2. Okay, x plus 7 x minus 2. Let's see now, what's my LCD here? Looks like LCD is x plus 7 x minus 2. Now usually I think about extraneous solutions at the end, but it's maybe easier to just think about them right now as well. What values of x will make your denominator 0? If x becomes +2, then my denominator becomes 0. Or if x equals -7, again, my denominator becomes 0. Once we have found the LCD, we are going to multiply both sides of the equation with that LCD and distribute that into every single fraction inside. So I'd be left with 3x times x minus 2 because x plus 7 will cancel. 3 times x plus 7 because x minus 2 will cancel. 5x plus 17 only because both the denominators will cancel. Both factors in the denominator will cancel. All right, let's go ahead and distribute, combine like terms. 3x squared minus 6x minus 3x minus 21 minus 5x minus 17. Okay, 3x squared minus 9x minus 21 minus 5x minus 17. 3x squared, add 5x to both sides. That would leave me with negative 4x here. And then add 17 to both sides. Negative 21 plus 17 would be negative 4 equal to 0. Now let's see if it's possible to factor this any further. We would be using the bottoms up method. Two numbers that multiply to give me negative 12, which is A times C, and add up to give me negative 4, which is B. While my two numbers are going to be 6 and 2. And we'll make the 6 negative because we want them to multiply to negative 12 and add up to negative 4. Divide them both with the 3x and 3x. Cancel, simplify the fraction you can. So my two factors turn out to be x minus 2 and 3x plus 2 equal to 0. So my solutions come out to be x equals 2, x equals negative 2/3 when you plug each factor equal to 0 and solve for x. Okay, now is any of these extraneous solution? Well, x equals 2 is. If you look, we found the list of extraneous solutions earlier and we said, oh, x cannot equal 2 because that makes my denominator equal to 0. So only allowed answer or okay answer is negative 2/3. Negative 2/3 is the only answer that is okay, that does not make my denominator equal to 0. Right, let's look at next example. X plus 5 over x plus 1 equals x minus 5 over x minus 2. So what's my LCD in this case? Again, let's start by thinking about LCD. LCD would be x plus 1 times x minus 2. So I'm going to multiply entire equation, both sides, with x plus 1, x minus 2. Let's go ahead and distribute the entire, this LCD into both sides of the equation. X plus 5 over x plus 1 times x plus 1 times x minus 2 plus 1 times x plus 1 times x minus 2 equals x minus 5 over x minus 2 times x plus 1 x minus 2. All right, it is time to cancel all the common factors between numerator and denominators, and then a lot of foiling involved here. X minus 5 times x plus 1. All right, let's start foiling. So x squared first, outer, inner, last. First, outer, inner, last. And same thing on the other side of the equation. We have more first, outer, inner, last. All right, let's combine all the like terms and see what we can cancel from both left and right hand side. There's an x squared on left side, x squared on right side. So x squared, negative 2x plus 5x is positive 3x. 3x minus 2x is positive x. Positive x plus x is plus 2x. Negative 10, negative 2 is negative 12 equals negative 4x minus 5. X squared, add 4x to both sides plus 6x plus 17 equal to 0. That does not look right. So let me double check. X plus 5 over negative 12 plus 5 is not 17. That is a 7. All right. Yes, now it will be factorable. And it would be negative 7, right? Negative 7, because we have negative 12, equal to 0. So let's go ahead and factor this equation now. We are looking for two numbers, multiply to give me negative 7, add up to give me positive 6. So x plus 7, x minus 1 are the factors. When we plug each factor equal to 0, we get two solutions, 1 and negative 7. Now, before I box circle, I must think about what are my extraneous solutions. which solutions are going to be not allowed solutions here? Well, there's actually two restricted values in this case, x equals positive 2 and negative 1. They're going to be not allowed because they make your denominator 0, but the ones we got are positive 1 and negative 7. And they both are okay, so they both are my solutions. Okay, positive 1 is not a troublemaker because if your x becomes positive 1, you don't have 0 in the denominator in your original equation. Okay, so positive 1 is not an issue at all. Let's see one last example, one or two more, and then we'll be done with these. So first step, I'm going to be factoring every single denominator because I want to think about LCD. 1 over x times x minus 3. LCD in this case would be x times x plus 3 times x minus 3, actually x squared. So remember, we talked about LCD is bring every unique factor with the highest exponent. So that's what your LCD is. Now multiply entire equation both sides with x squared times x plus 3 times x minus 3. Now we're going to distribute, multiply every single fraction inside with that LCD and simplify. 2 over x plus 3 x minus 3 times x squared times x plus 3 x minus 3 equals 1 over x squared times x plus 3 x minus 3 plus 1 over x times x minus 3 times x squared x plus 3 times x minus 3. All right, so all this is gone. 2x squared equals x plus 3 x minus 3. We're just canceling the common factors between numerator and denominator, and then we have plus x times x plus 3. Let's go ahead and distribute and FOIL and combine the like terms and simplify from there. 2x squared equals x squared minus 9 when you do first outer inner last, plus x squared plus 3x. Now bringing all the terms to one side, we have 2x squared minus x squared minus x squared minus 3x plus 9 equal to 0. Now looks like I would not have any x squared terms in here. It turns out to be a linear equation, which is negative 3x plus 9 equal to 0. Negative 3x is negative 9. X turns out to be 3. Now, is that allowed solution? Let's check. 3 is an extraneous solution. Why 3 is an extraneous solution? Because that makes my denominator 0. 3 is an extraneous solution. So if 3 is an extraneous solution, we cannot include that in our solution. We just cross it out and we say there's no solution in this case. No solution in this case. This equation has no solution. All right, one last example. 4r minus 4. So let's go ahead and factor the denominator first. Two numbers multiply to give you negative 14 are r plus 7, r minus 2 plus 2 over r plus 7 equals 1 over r minus 2. So in this case, my LCD turns out to be r plus 7, r minus 2. Let's go ahead and multiply entire fraction on both sides with r plus 7, r minus 2. Distribute, distribute, distribute. So 4r minus 4 plus 2 times r minus 2 equals r plus 7. After canceling all the common factors, so we have 4r minus 4 plus 2r minus 4 equals r plus 7. Again, looks like it's a linear equation. 6r minus 8 is r plus 7. 6r minus r is 5r minus 15 equals 0. And then we can say 5r equals 15. Actually, to make my life easier over here, I'm not going to bring 15 to the left-hand side. I will just add 8 to the other side and make it equal to 15. R turns out to be 15 over 5, which is 3. Let's go ahead and check what are my extraneous solutions in this case. Remember, extraneous solutions are the ones which make my denominator 0. Extraneous solutions extraneous values, restricted values are r equals -7 and +2. And r equals 3 is not one of them. So it's okay to box, highlight, and circle this answer and say this is my solution. Okay, here were the 8 examples for solving